it just doesn't seem to fit.
Wait, did you hear that? Wow. I think I live on a street. I'm sorry. It's New York City. It's not like the crazy part of New York City, but it is New York City. It appears to be a fight.
So welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to really think about pedagogy, teaching and learning, professional development, anything of interest to time-poor but enthusiasm-rich primary teachers. This week, I'm joined by Christopher Such.
Hello again.
And Michael Pershan.
Hi.
And I had to say, it's an absolute honor to have you here with us, Michael. Really appreciate it. Big fans of your work, and really looking forward to this conversation. But first, Chris, what you reading for?
Hey, what you reading for?
This past week, it will come as no surprise to people that I've been reading about reading development. I continue to read the brilliant book, The Science of Reading Handbook, which came out a month or two ago. In particular, this week I've been reading a chapter called Learning to Read Words by Anne Castles and Kate Nation. It covers some ground that is in the paper that the two of them, along with Kathleen Russell, contributed to Ending the Reading Wars, but it goes into a little bit more detail, in particular on word recognition. The thing I love about it in particular is that it elegantly explores different aspects of word recognition using a framework of sub-lexical level learning and lexical level learning, a fancy way of saying, well, let's look at the bits of decoding that involve us breaking down and analyzing words, and let's look at the parts of word recognition that maybe involve the development of things like a sight word lexicon and mispronunciation correction, which we discussed last week, or a couple of weeks ago, I should say, with the brilliant Danielle Kohlenbrander. I know it's an expensive book, so it's really one for the research geeks amongst us when it comes to reading. But if you do take the plunge, you won't regret it. Michael, what are you reading for?
I've been reading a lot about homework research lately. I've been trying to make sense of it. I think it's, I don't know, it's a fascinating area of research because it seems so straightforward that you'd expect that students who are assigned practice learn something from it, but it's incredibly difficult to measure this thing. And as late as 2003, my favorite paper that I've read as part of this thing, as part of this kind of little dive into homework research, is by, I'm trying to get it, they're German, and which means that I'm about to mispronounce their names, but Trautwein and Kohler, Trautwein, and I don't know, but it's called The Relationship Between Homework and Achievement, Still Much of a Mystery. Now, to be fair, that's from 2003. So I don't know, it's not as much of a mystery as it was in 2003, but at that point, homework had been studied and researched for about a century. And people have been talking about, does homework impact achievement and help kids learn for about 100 years? And to say in 2003 that it's still a mystery, I think it's a wonderful read, and it's surprising, and it was eye-opening to me to realize that something that seems so straightforward could really be so subtle. And it's challenged how I think about homework. It's made me think that the relationship between, if you're doing homework because you think it'll help kids learn a lot, you might want to take a deep breath and think about whether that's sufficient, because it's not as straightforward as you might think. What are you reading?
So I think part of what I'm reading links a little bit to that, because it's by David Geary. I'm going to give anyone who's in the car with their kids the chance to turn the volume down for about maybe 5 seconds. But the paper is called Sex, Mathematics, and the Brain, an Evolutionary Perspective. And I know obviously in this case they're talking about gender, but I want to keep that non-explicit rating on the podcast. But essentially, it's a collection of works looking at how we've evolved and the impact that might have on gender differences. I think that's sort of a general way of looking at it. And so for me, big fan of David Geary's work, but I've always thought of gender differences as something of a self-fulfilling prophecy. So I'm very keen to go further into it. You know, I've read David's introduction, and next I'm going to see what the other authors have to say. And at the start, he talks about differences in culture and attitude, and he cites some homework papers as the difference sometimes between high performing jurisdictions and non-high performing jurisdictions. So maybe I'll send those your way, you know, because the jury is out in terms of homework. But I think yeah, when David Geary writes something, I'm going to read as much of it as I possibly can. So this week, we're going to focus on self-explanation. And my first question is, when we say self-explanation, what are we referring to?
It's an excellent question, because I think something that researchers have only started becoming more sensitive to is that there might be several different things that are called self-explanation. So maybe we should start with the beginning of worked example research. And which, by the way, part of being a parent of young children and also a teacher in the beginning of the summer is that my brain is addled. I don't remember things anymore. I don't have citations in front of me. I'm not a researcher. So as much as I'm gonna make mistakes here. So I'm just giving myself permission for that. But my understanding is, you know, I love the story of cognitive science. I love the whole sweep of it. By the 80s, cognitive scientists were studying problem solving. Sometimes people in math education call 80s the problem solving decade in kind of like a self-important way. But that's where worked example research, my understanding, is where it comes out of, is the realization that if you could learn from problem solving, you could also learn from studying solutions. And that might be more efficient in a lot of cases. So that's happening. People are studying worked examples and learning from worked examples. And there's I think it's Chi, right? Who says for the first time, wait a second, there's actually differences in how people study worked examples. As a matter of fact, stronger students study worked examples differently from students who go on not to reveal that they haven't learned very much from it. Students who are later successful study examples in a more careful way. And she asked people to say out loud what they were thinking as they were studying the worked example. And as people did that, she heard, as they were talking out loud, like, okay, so there's this over here. What's that? Oh, I see. That's this, that. She called that self-explanation. And she noticed that some students do this and some didn't. And she said, well, the students who do this are more likely to be successful in their later problem solving than the ones who don't. That's the beginning of it. Cut to, 20, 30 years later, there's a lot of research that claims to study self-explanation. By the way, Chi's reaction to this realization was to prompt students to self-explain. But she herself, I think, didn't see self-explanation as necessarily a verbal thing. It wasn't necessarily a verbal, clear, explicit articulation. It was some other thing. What's that other thing? It's not entirely clear. And so as people are studying self-explanation, there's this kind of cloud of a lot of different things people are saying. It's about attention. People who are self-explaining are paying more attention. Or maybe it's that they're actually offering explanations. Or maybe it's that they are realizing a self-assessment and self-regulation. They're realizing things that they don't understand. So those are really different effects, like cognitively, right? There's a difference between greater attention, self-regulation, and realization, awareness of basically online awareness of gaps in your understanding that you're then motivated to try to correct, and some effect of actually articulating an explanation. So what is this? I'm really fond of this this attempt by Renkel and Eitel to in this chapter about self-explanation to try to clarify this a little bit. So what I think that they do, which is super smart, is they start by saying there's a lot of things that self-explanation might be. So they narrow in on one of them, one specific self-explanation effect that they think is real, and they think it's about generalization. It's about, you have a specific worked example or a specific solution or a specific whatever that you are studying. And How do you, you want to apply that to some other thing? That's the whole point. Abstraction or generalization is how you do that. You have this very dot, you've got a specific thing, and you need to kind of make that apply to more things. You have to take something out of that you can then apply to something else, so that this problem and this problem, which are different problems, are connected. So he says he's interested in a kind of self-explanation that does that. That supports generalizations. And I think that's smart. I think that clarifies what we're doing. And I think that's where self-explanation can help. It can help make generalizations that you can then apply to more problems.
I mean, it's really interesting you mentioned attention, because, and one of our sort of early career teachers, I'm exploring your sort of model for worked examples, and we're looking at, well, what's the distinction between, say, the silent teacher, which we've been using in the school for a while, and breaking things into sort of more component parts. And we noticed that the pupils would pay attention to us more than they would pay attention to the worked example in those initial stages. And we thought very carefully, well, how are we going to get, because you obviously talk about how important it is that pupils who spend more time quietly analyzing tend to sort of understand later on. I think, yeah, so really interesting that, I can see almost the opposite, pupils struggling to sort of spend their attention in the right direction.
First of all, I mean, something like that kind of pattern of behavior is going to be really, I think, sensitive to a lot of things that don't have to do just with self-explanation, right? I've been teaching my students for months and months and months, so they know what to expect when I do a thing, and maybe that impacts how they direct their attention. Or they're older students, or they're younger students, and younger students approach school differently. They interact with teachers. They think of their teachers differently. They might be more troubled by their teacher doing something funny. So attention's a kind of fickle thing. But that's an observation you're making about, I feel like the sensitivity of routines to context, and the difficulty of saying, hey, here's the set of actions you can do that'll work in any situation. It needs to be bigger, that flexible, or more flexible, and more principle based, really, so that you can say, wait, I'm having this problem, I need to adapt it this way. Right. So I feel like the outcome of any kind of pedagogical discussion needs to be a little bit more abstract than just a bunch of behaviors if we're going to apply it widely.
Can I ask a very basic, follow-up question along these lines? I mean, you've obviously looked at the research into self-explanation a great deal more than I have. The bits that I looked at talked about things relating to, it was quite broad, but they also mentioned inference in reading. So they were saying here is, in short, self-explanation is useful when there's a gap between two things, as you say, a generalization or some kind of leap where knowledge that pupils already have has to be brought to bear in a new context through which they may, learn to generalize in some way. And the thing about, say, comprehension strategies that relate to this is that the idea is that you can teach them, use them. So a kind of form of self-explanation that has effects that go beyond the immediate learning context. So it isn't just, this is a useful way to teach this bit of content, but it's also something that has kind of wider effects, perhaps because of the way it changes pupils' attention. Is there any element of that in the research? In other words, is there an extent to which they're saying getting children into the habit of self-explanation has a wider impact upon learning? Or is the research particularly saying, no, when you teach this thing, it's better for learning this thing if you use self-explanation?
You're saying, is it almost like a metacognitive thing that you can then say, oh, when I'm reading something, I should prompt myself for self-explanation? Is that the idea?
Yeah. So is there does the research make that kind of suggestion, or is it specifically saying, no, it's a useful way to learn about X, Y, or Z?
Well, I feel like now we're moving away with that question, away from self-explanation research itself and closer to self-regulation learning, and that because I think from the perspective of researchers doing who I've read who are looking at self-explanation, they're looking to prompt students. The big idea is let's prompt students and improve their learning from an example or from a pair of examples or some other learning activity, but let's prompt them to self-explain. Now, yeah, so the first thing I'll say is just like, I don't know, I haven't seen a lot of that in the things that I've been reading. But I think the suggestion is that probably going to find like a more of a home in other areas of research than in self-explanation research. And I don't really know that stuff so well. But the other thing I wanted to say is there is a kind of, here, I want to say one thing about research and then just one thing about my opinions. The thing about research I want to say is that I'm really fond of another article by Bethany Riddle Johnson and some colleagues about that I think is a review of research on self-explanation. And I think it condenses it into I think 4 principles that are relevant for teachers and anybody working with kids. And in one of them, she points out, and this is just summarizing a point that others have made, but she's putting it in a nice way. She points out that if you tell students, go ahead and explain this to yourself, as a self-explanation prompt, and students don't know what an explanation is, that's massively unhelpful, right? Right. Students don't always know how to explain things. So if you prompt them to explain them to themselves, that's not necessarily going to help at all. Or if you ask why is 7 + 8 greater than 2 + 9. I work with 7 to 8 year old. No, I guess 9. I always forget how old my students are. Isn't that weird? Okay, but 9-year-olds or such that would just be like, well, because I did it, and that's not going to generate good generalizations. That's not going to really do much except draw attention to the fact, which is something, but that's not deep thinking. So what do? So there is a kind of hope that maybe by teaching self-explanation, that is a kind of reciprocal relationship with explanations. I don't remember really seeing any evidence for this. I think it'd be cool. But there's a kind of understanding that you might need to, and there are attempts to instruct students in how to give good self-explanations. And I believe that there are, don't quote, I mean, whatever, we can look this up. I think I saw in that article, if I'm remembering correctly, I think she says, but I didn't look carefully into, but I think she says that there were attempts that to train students in giving good self-explanations, and that these had some measured impact on their ability to self-explain and learn from it. So maybe that's that, right? Maybe there's a little bit of that, which is what I think you're suggesting, right? That there's some persistent, that's not saying that, right? And that's saying like, if you train students, maybe they'll take something away from it. If you train students how to give a good self-explanation, maybe that'll carry on. I mean, the other thing I wanted to say is, I think in terms of just myself, my life as a teacher, this is not a research-based opinion, really. It's just, there's a lot of things in education, in my teaching life, not education, in my life with students, where I have hopes, but I'm not betting on them. You know what I mean? I love that, that lesson that I did, where I kind of encourage students to be creative and solve a challenging problem that I thought they were ready for. I'd love for that to kind of inspire them to approach more challenges in their own lives, to approach similar problems in their own lives. Or sometimes with my younger students, especially, I share logical puzzles. I hope that'll spark a love for logical reasoning, and to realize that that's part of math, and that years from now they'll realize, I love Sudoku. I love using my brain. I love thinking carefully about things. So I have those hopes. At the same time, life is very short term, right? And I know that that's kind of a long shot, and I know that that's not measurable. So as a teacher, I have all these things that I'm just kind of doing because I think they're good ideas right now, but I also kind of hope that they might last, that they might have some kind of longer impact. And what's the worst that could happen? As long as it makes sense, as long as there are things that also make sense to do now, as long as I'm not making massive trade-offs, I'm okay with saying, I don't know. I don't know if this is going to help. I hope it does. That'd be nice, wouldn't it?
Yeah, no, I love it, because what your ambition does is it ties up, you know, worked examples, a more traditional style of teaching with the aspirations of all teachers of mathematics. You know, sometimes one of the criticisms leveled at that particular style of teaching is that it doesn't ask pupils to go deeper, and it doesn't ask them to make, you know, generalizations with regards to the beauty. But actually, what you've just described there, you know, you couldn't have higher ambitions for your pupils. And I think, you know, it definitely makes sense to me that you could realize those ambitions through the sort of approach that you're talking about and promoting.
Right. And if it doesn't work out, then I've just done a research-based thing to try to help them learn from this specific example, right? Like the cost. I kind of like things in teaching and education more broadly that, you know, the worst that could happen is that it's good now. And the best that could happen is it's good in a bigger sense, you know. I think the controversies that show up sometimes are when teachers or whatever other people in education say that you should trade off. You know, don't do what's good, what seems good now for the test. Instead, focus on things that'll be good for some other reason. I think of like projects, you know, inspire a love of mathematics in your students. Isn't that much more important than, you know, passing this test? Or you know, a love of reading, isn't that more important than you know, their ability to succeed on whatever examination, or what other, you know, to know proper grammar or something like that? I don't know. But I like things that are both. I like trying to find that narrow path that kind of, I'm trying not to make too many big trade-offs in either direction, because that way I can try to stay sane.
So you've given us a kind of explanation of self-explanation, in particular relating to this idea of generalizing. That being the case, would you say that there are aspects of mathematics that self-explanation particularly lends itself towards? And obviously with that, are there areas of mathematics where you've used self-explanation as part of your way of using worked examples and then gone, no, actually?
Okay, but you're asking about whether self-explanation is more useful in some areas. Well, let me talk a little bit about geometry and shapes, which I think, you know, I always sometimes, by the way, we do it in secondary school in the US. We do it in a kind of silly way, I think, compared to the rest of the world. I think the rest of the world's got it right, which is that you teach a little bit of geometry mixed up with everything else. And then, but the way in our wisdom we've been doing it, and we'll, because it's the United States, we'll probably do it forever, is it's a separate course. You take an algebra course in secondary school, you take a geometry course, you take another algebra course, and then you take a pre-calculus or whatever course. But so there's a year, and sometimes I teach that. I've taught that a lot, a geometry class, and I tell students, you know, geometry is often really different from algebra. It feels really different for a lot of people. But part of that is because algebra and geometry are, you know, algebra is more connected to the arithmetic that students have been doing for a long time. Part of it is just that they're different disciplines, and problem solving as we experience it in school is, it just looks different, right? It looks different. Culturally, we've decided that geometry should, when students solve geometry problems, it sometimes is not a numerical computation, but sometimes it's a proof, which is, you know, a lot of mathematicians would say that is more important than people realize from their school lives, the proof and explanation itself. The point I'm trying to make is that geometry is, I think, sometimes a little bit trickier for all the worked example and all the self-explanation stuff than algebra and arithmetic problem solving. Or when I find myself in other areas of math that are less algebraic, I need to sometimes say, wait a second, how does this apply here? The problem with geometry proof, I don't know if this is part of your lives. Is yes, no, familiar at all? Whatever, geometry proof, I sometimes have to teach students to prove things. I have to say, okay, here's a parallelogram. It has these things. Prove that it's definitely a rectangle. Prove that all its angles are 90 degrees, actually. And they're supposed to infer from the sides or from the given information about the angles or whatever. That's a little bit harder because it's a little bit harder to define, for me at least, the area that we're trying to teach. A lot of these things, I have to say, wait a second, this is a parallelogram problem. So when I ask students to self-explain in that context, I'm often having a hard time thinking, wait, what is the generalization that I'm going for here? Like, I have to think very hard. Whereas with algebra problems, it's often really easy for me to think about. I say, wait, what if the numbers change? What if this equation looked a little bit different? I'm trying to teach them to solve a quadratic equation that is clearly defined. With geometry and proof especially, sometimes I find myself saying, wait, what am I doing? Am I trying to teach kids just to prove anything? That doesn't make any sense. Does this make any sense what I'm saying at all? How about,
Yeah,
would that be
100%.
Yeah, 100%. Like,
okay.
I could imagine trying, like, if you are trying to get someone to deduce a proof for something geometric, once you've done it, then you're going, okay, so how does this apply to other proofs? Well, it doesn't necessarily. The proof itself is almost itself a generalization rather than something that applies elsewhere. Have I cottoned on?
Exactly. I think that it's part of why it's sometimes hard to port the self-explanation work example stuff into something like, I don't know, secondary English, where you want to say, okay, should we use self-explanation to teach students how to craft a compelling story in a creative writing context? Well, I don't know. The product is, on the one hand, so specific, and the context is so, in a way, idiosyncratic, and the domain beyond that is just everything, like writing fiction. So if we say, like, okay, here's a model of a great story, or a passage from a great story, or a paragraph, and now you're going to write a paragraph in whatever Faulkner style, and now give a self-explanation about what you did. What are we trying to teach? We're trying to describe Faulkner's style, or are we trying to make a greater point about how a paragraph should be constructed? It would require a lot of creative thought, and it might not even be true to how we want to teach these things. It might be kind of awkward. And that said, in the mathematical case, which even with geometry, I've always been, I find it really productive to think in that way. I really found it productive. It's not as natural, but I find it really productive to say, wait a second, I'm trying to teach students how to prove that something along the lines of the generalization I'm aiming for is, if you find yourself in a similar triangles problem, first find all the angles. That's what I'm trying to prove. That's what I'm trying to teach, rather. I'm trying to teach that, So those articulations, I think, are just harder to come by, but I think they're true. And I think that I've always found it. So I wouldn't say that self-explanation doesn't work as well there, as much as I think a lot of the pedagogical structure of some areas of math is just less well understood and less transparent, which I think actually points to part of it is that we've been teaching algebra for a bunch of years. Part of it is, I think, that's what's special about algebraic problem solving. Its structure is so visible and clear. Also, arithmetic. It's so clearly. Sometimes with arithmetic, the problem is that it's so clear that students aren't sure what to say. Like, what they've done is so transparent. And then, so I part of that is, I think, that the technology of numbers in algebra is itself really clear. That's the problem.
Yeah, I think listeners around the world will relate to that. Certainly in my own experience, geometry is probably the most underserved part of the curriculum. And it's the last one to be exemplified when we have discussions about mathematics. It is much more natural to opt for algebra and for arithmetic and problems of number. And so yes, I completely see where you're coming from. And although we aspire to proof in our national curriculum here, I don't think we get anywhere near close to it. I don't know, what do you think, Chris?
Certainly not in the primary curriculum, beyond the basics of, say, proving that something can't be true using a non-example of something. That's about as close as we get in before kids are kind of 11, 12, and they go off to secondary. So it's fascinating to hear you say there. One thing I'd add, though, I think what you said there about writing and generalization is really, really interesting. I think your really onto something. But it's worth noting that I think there are aspects of teaching writing, particularly at primary level, that do lend themselves to some kind of self-explanation, precisely because they do have some generalizations. So let's say, particularly when you're learning about certain nice, clear genres, like you want children to learn about a fairy tale, and there are certain generalizations that you can make about, the good guy and the bad guy and the happy ending and this sort of thing. Whereas you get into other aspects of writing, and this attempt to generalize just falls apart to some extent, because you can't. There isn't a nice generalization that you can bring to bear. Yeah, so I do think there are some aspects of writing, but you're dead right. I just looked down at my notes and saw that there was the Riddle, Johnson and Lur, almost certainly pronounced that wrong, 2016 paper that was saying that a problem with self-explanation can be overgeneralization, which makes it particularly useful for areas of learning that potentially have certain rules and heuristics, like maths and science, and less so for the subjects where perhaps there aren't these nice rules and heuristics.
So I also think, this is just a random opinion, but overgeneralization is part of learning. And I feel like even great artists, people sometimes when they're talking about craft, talk about copying or finding mentors and then kind of trying to slavishly imitate them until your own unique style comes through. There's a kind of overgeneralization that is natural in learning that can sometimes be problematic, and sometimes you can avoid that and making that. I'm thinking of things like how students sometimes overgeneralize from simple equations to the extent that they don't really know how to comprehend more complex equations. They misunderstand the equal sign. But sometimes it's just, I don't know. Overgeneralization is part of life. If you learn something, the tendency is to try to apply it. So I agree with everything that you said. I sometimes wonder if, math educators sometimes say, the problem with teaching it this way is that kids will, make this mistake in the future. I've seen that. The case that comes to mind is, some people are opposed to teaching children that if you multiply by 10, it's just adding a zero, multiply by 100, you just add 2 zeros. The simplest thing in the world, right? But there are some mistakes that kids will make when they know that. They'll overgeneralize that to like decimals in wrong ways. But that's, I don't know, it's part of life a little bit.
Yeah, I think however carefully you teach that, children are going to make those overgeneralizations. I mean, even if you do teach that through a deeper understanding of place value, etc., kids are still going to go, oh yeah, I did, but I do lots of questions and often I just add a zero. So however careful you are, they are going to draw these things out. So being ready for that further down the line, I think, is part of good teaching.
Yeah. It's an explicit part of the Singaporean curriculum, if I remember correctly. So, who am I to say that they're wrong when it comes to things, curriculum design? So, yeah.
I mean, I love Singapore. Don't get me wrong. Okay. If anybody from Singapore is listening, I use your materials all the time. However, Singapore, this is it. I'm going to do it on your podcast. I'm going to say Singapore has some things they can do better.
You can't stop there.
Yeah, you have to tell us more. Give us some examples.
Let's see. Well, okay, I've given students. No, this will be silly and petty. Like the illustrations sometimes in them, where like there's like a fish playing basketball, and just kind of why did we need that fish playing basketball? No, and sometimes it feels like things escalate quite quickly without enough practice in their curriculum. 5 times 10, 50, 57 times 32. Excuse me, pardon. Wait. Wait, that's lesson 2?
We use a Singaporean material as our main textbook, and we have to, during our planning sessions, because everything's mapped out, we will think about where the pupil's going to get stuck and what questions are structurally similar enough that we can give them maybe 6 or 7 more to practice, because they're not going to go from A to F and picking up those connections. We need, yes, we spend a lot of time thinking about the structure of the questions that we know pupils will fall down on. Yes, I totally get that.
Yeah, but it's good materials and good visuals. Except some of the bars are needlessly complex. So I'll say that also, Singapore. Yeah, I'm sure if kids get good at it, I'm sure you can teach kids, and some of that complexities, what are you going to do? But some of it, it's a little bit too much.
From my experience, there are certain, I mean, I love a bar model, big fan of a bar model, but there are certain questions, and Elliot Morgan will be delighted to hear me say this. There are certain times and certain questions that feel so unlikely, so fabricated. So it's like, you've just created this question so that we can do something with a bar model, rather than so that we can understand a little bit more about the mathematics, or at least that's my experience of some bits and pieces that I've seen from a particular textbook, different to the one Kieran's talking about, a particular textbook that is based on Singapore maths.
Yeah, well, I mean, Singapore itself, they've got like a lot of different books in their series. I often find that I can kind of triangulate between them and come up with something plausible for my students.
When you describe what's going on with self-explanation, there's obviously an extent to which there's a gap between what you are showing to pupils and what you want them to infer. And there is a sense, particularly thinking about your sequence for worked examples, in which there is this prompted inference that pupils are doing. You are saying, like, here it is, have a think about this, analyze this yourself, then have the opportunity to talk about that with a partner, and then we'll discuss it a bit further. Is there any way in which someone might say, well, are there elements of discovery learning there? Is there a sense in which you're missing an opportunity just to say, this is how it works, I'm just going to explain it to you? Or would that be a particularly unsubtle and unfair way to characterize self-explanation as a sort of discovery learning?
It's a really interesting question. And I think it cuts to a lot of the core things that we want to talk about. In my mind, there's two things to talk about primarily. The first thing is you talk about a gap or some inference. But what activity that students do, that a teacher asks a student to do, I think literally all of them, there's always a gap, right? 5 plus 7 equals what? I could just tell you it equals 12. Why don't you figure it out? Is that discovery learning? Analyze this worked example and figure out what this is happening here. Is that discovery learning? I haven't told you exactly what it is. And why don't I just tell you? Why don't I just tell you that 5 plus 7 equals 12? So let's take even the first is, I think it's not unusual, not necessarily unusual compared to other things we ask students to do, to ask students to provide a self-explanation. But I think that's answering the question in a narrow way. The big question, the second thing that we should talk about is, like, what is discovery learning, and how does it relate to all these other things? So, or to put it a different way, what's wrong with discovery learning? If we ask students to make inferences all the time, if we ask them to do 5 plus 7 equals 12 all the time, and if what's the difference between that and discovery learning? You might say something I think is not going to work out. You might say, oh, well, I've taught students how to do 5 plus 7 equals 12. And you know what? Maybe you have taught students how to do 5 plus 7 equals 12. Maybe you've written that on the board. But have you written 21 plus 37 equals, have you done that? You haven't done that, is the point. You've taught, you've given an explanation, maybe a direct explanation, sure, of how to solve this class of problems. Absolutely. But you haven't done that problem. There's a jump. There's always a jump for any real practice. So that can't be the existence of an inference, a leap that students have to make on their own or left to do on their own can't be what we're talking about here. So I would propose that when we talk about discovery learning, and what's wrong with it really is just what distinguishes it from practice, right? It's not the type of task, it's whether students are prepared to be successful at it, or whether they're prepared to be unprepared for that and they're likely to be unsuccessful at it. Right? I mean, the same task, the same discovery activity is often indistinguishable from an application problem later on. So let's clear up the landscape a little bit, and let's forget discovery, I think, and just talk about let's look at some basic, I don't know. I would posit the following things. I'd say what's good and what's bad. What's bad are kids not being able to do things, being given a task that they don't know how to do, and they approach it in a way that isn't fun, isn't interesting, isn't important, and is often frustrating, and they can't learn from it. And what's good is tasks that get kids thinking about cognitively appropriate things that are important for the discipline, things that'll help them later on, and that they're ready to do it. And we also want to trend towards more independence. I think those are relatively uncontroversial things. You can always find a controversy in teaching, but I think that in the scheme of things, that's relatively uncontroversial. Kids shouldn't be like flailing around purposely. They should be relatively successful in the things that they try to do. It should be appropriate and important stuff for them to learn. Look, and we're trending towards independence. So let's talk about, I think with things like explanation, that can be anywhere on that same continuum. We can ask kids to explain, and they can not be prepared for that, and they will fail, and it wouldn't be interesting, and it wouldn't be something they're successful at, and it wouldn't be important for the discipline and their learning. It's just kind of a waste of everybody's time. That would be, I guess, if you want to call that discovery learning and say that that's ineffective, I'm okay with that. If you want to call that just bad planning, I'm okay with that also. And then there's self-explanation can be further down that line. It can be things that they're prepared to do. You can directly instruct students in effective self-explanation for a lot of types of problems. As a matter of fact, I think I don't remember which riddle. I don't know if it's the Riddle-Johnson review from 2016 that you were talking about earlier, the one with Lair. But it's that one I was referring to earlier. Part of that review, and I think this is so nice, is I think the axiom is what matters is what kids are thinking, not who prompts the thinking, not who came up with the idea primarily. The thing that leads to learning is thinking hard about it. If you share an idea with me, and I think a lot about it, and I think about it hard and deeply, and I flexibly, and I kind of mull it over, and I think about how to apply it, I'm learning, even if you come up with the idea. So that's the kind of insight that leads people to say, oh, discovery learning versus direct instruction. There's no real advantage for discovery learning, at least not a cognitive one, on the narrowly defined question of efficacy learning in the session or whatever. I'm trying to ignore motivation stuff, but the same thing can be said with self-explanation. It doesn't really matter who generates the self-explanation as long as people are thinking carefully about it. Now, how do you make people think carefully about something? So there's interesting scaffolds that Riddle-Johnson collects in that little paper, and Renkel has some of these also. Some of it's from Renkel's research too. Things like multiple choice self-explanation prompts, like what best explains. And I've tried this a bit in my classroom. I like it. Like, what best explains why Kieran's solution worked? Option A, he made it up on the spot and nobody cares. And option B, something smart. A triangle's side angles always add up to 180 degrees. That's kind of a generalization that if you give students multiple choice, they can still kind of think carefully about the meaning of it and benefit from self-explanation prompts in some of these studies, even though they didn't generate it. And what I'm trying to describe is that that's a scaffold, the same way you'd scaffold problem solving. So I think the way I think about this stuff, and I think it's useful to think about it, is let's just think of explanation, and self-explanation is just another thing we're teaching, another kind of task that we want students to be able to do. And we can scaffold them. We can support them, with it if they're not ready to generate it on their own. And if they are able to generate it on their own, they can. That's great. It's like problem solving, right? When you're ready for independence, you should do it independently. When you're only able to do it with support, you should do it with support. If you need direct instruction, let's give you just some direct instruction. It's just like another thing in the universe, not some other thing apart from regular teaching.
Yeah, love that. Great answer. Just as a defense, because I recognize that was a slightly provocative question that maybe doesn't reflect my thinking. I've got like written down in notes here, like there's always a leap. I mean, even with a clear explanation, even with 7 + 5 = 12, there's still a leap because you'll be using words. Like in pretty much all cases, kids are still having to make some kind of cognitive leap. And the question isn't like, is there a gap or isn't there a gap? Arguably, as you say, with your idea of a continuum, it's often, well, what's the size of that gap? Are we asking pupils to make a leap that is just about within their grasp, that is cognitively demanding, but not so impossible that they've got no chance of success? So yeah, absolutely. Yeah, love that answer. Thank you.
Yeah, I mean, I didn't mean to come down too hard on the idea. I just think that a lot of discussions about discovery suffer from, I don't know, like general lack of clarity about what we're talking about. General lack of clarity about like realistically, right? I mean, there's obviously you can't teach, like you can't, I'm gonna say a ridiculous thing. You can't teach kids everything that you can't cover. You can't we are in the business of helping kids do things on their own. It's important not to kind of express absurdities in the context of talking about discovery learning. That like this, I don't know, sometimes people say silly things. And one of the silly things that people sometimes say is that kids learn everything better when they discover it on their own. And that's obviously absurd. And, it's also absurd to say that you could cover explicitly everything that a student is ever going to come across. You just can't.
On this point you were making before about this like continuum as well, and the idea of it not being as simple as all that. The Bisra, I think, et al. Paper from 2018, Inducing Self-Explanation and Meta-Analysis, talks about potentially there being a value to matching the prompt that you give as part of self-explanation to the level of expertise of the student, which I just thought, I saw that in my notes and thought that just tied in beautifully with what you're saying and suddenly kind of made sense in my head because of what you had said. So I thought I would bang on about it.
Is that ITEL you said? ITEL?
Oh, sorry, no, Bisra et al. So Bisra and, sorry, yeah.
Oh,
and
the other, yeah.
Sorry, it's called Inducing Self-Explanation and Meta-Analysis. I don't know if it's particularly great. It just seemed like quite an interesting paper on the subject. It was the one that kind of I went to because it seemed to summarize bits and pieces for a novice like me.
Yeah, the other, I wasn't sure because the other, I thought you were talking about Rankel and ITEL again, because I think that they're responsible for the other technique I've seen for scaffolding, which is deleting, like making it a fill in the blank exercise, but the words you delete are inessential. So you get both a model of a lot of the explanation is modeled for you right there. Something like what's the one I said a second ago? The 3 angles of a triangle always add up to 180 degrees. So you might say like the blank angles of a triangle always add up to 180 degrees. If that's all that students are ready to complete on their own, hopefully they know how many angles a triangle has. But then they're engaged in the sense that they're doing, because problem solving is engaging, right? That's what that is. It's kids like people like answering questions. So you're engaged in trying to answer a question, but you also have the explanation kind of directly presented for you for your cognition, for your ability to take it in and say, oh, okay, this is. So that's another example of a scaffold that you might use for students who aren't ready to generate self-explanations on their own yet.
Yeah, I mean, quite often we'll find that there's a gap between our pupils' ability to articulate what they've experienced. So they might have a reasonable understanding of the mathematics, but when it comes to explaining in words, there's quite often a gap because they're coming in. It takes a long time for them to learn to read fully and to develop their sort of social skills. And it sounds like that kind of exercise will be quite beneficial in terms of giving people the confidence to think, oh yeah, I do know that. I understand triangles in this way, but I couldn't compose that sentence based, about the triangles.
I mean, I don't know if you ever find yourself, especially with younger students, doing this, but you know, there's some kind of whole class discussion, and the student says something, and then you say, "Can you try that again with the word, whatever the word happens to be? Try that again with the word inequality, behavior, equation. Try restating that, or writing on, you know, a word bank on for display during some kind of discussion. You know, here's the 5 words that we're going to try to use as part of this discussion." I think that this is going a little bit beyond the evidence, in my opinion. But I think that one thing that hasn't happened yet, that maybe could happen in research and teaching and education stuff, is to realize that the really explanation in a group setting, in a social setting, and self-explanation in a kind of more private individual setting are intimately connected. And I think it just makes sense to me, based on my understanding of how just like learning works, that students get an understanding that both self-explanation and communal social explanation are 2 sides of the same coin. And a classroom where we're always encouraging students to articulate themselves with sophisticated language and new concepts is going to enrich their self-explanation also. So I kind of suspect that what this is all pointing to is, I think, what we know, which is that we want our classrooms to be places where kids are talking in new and sophisticated ways, and we're always pushing their ability to articulate things further. And it's interesting because it does feel right. It feels like we're going beyond a narrower picture of what classroom life is like. I think that's the connection to discovery, right? Not so much like we're using the same process, more like we're expanding our sense of what has to happen in school. It's not just, you know, solving a problem. You couldn't learn to do this just by yourself at a computer. There's something social about explanation. And I think when we talk in this way, we're sort of saying, well, yeah, we need to have a full classroom where we're talking about why. And we should teach it the same way we teach other things. We should we should consider explanation kind of a curriculum goal, and take it as seriously as the problem solving, because they're connected. And I guess, you know, if that does feel a little bit like, you know, the progressives won. They were right. They were saying they were focusing too narrowly on problem solving, and we can't let them win. No, but what we can take away, you know, the balancing thing that I think traditionalists have to offer there is, well, you should teach it so they can do it. You should teach them well. You should teach them to actually explain in a way that's scaffolded, supported, direct, explicit, enables people to succeed. That's kind of how I see the balance. That I sometimes think of myself as a traditionalist with an expansive notion of what mathematics is and should be taught. So that's kind of, I'm attracted to that position.
That sounds like my perfect explanation for Kieran as well. A traditionalist with a bold, expansive view of what mathematics is and should be would probably be, I mean, I was about to say epitaph. You're a bit young for that.
Jeez, on your grave. This is getting dark.
Yeah. What's going to happen in season 5?
Oh my God. Season 5 of what show? One of your I don't know, English sad David Tennant murder mysteries on a deserted vacation spot.
Yeah,
shows.
I know the ones you're talking about.
Just Broadchurch. It's just Broadchurch. The only one I've seen.
We're moving slightly closer to the classroom, and I sort of, you know, mentioned earlier on that you've sort of almost got this model that you employ when exploring worked examples in general, but you've already sort of clarified that, you know, it's a bit more than that, and it's not just behaviors. But do you have something similar, or do you have an approach, you know, taking what you've learned from the research in terms of your preference for behaving in the classroom when it comes to self-explanation? Like, how would you encourage your pupils to explain?
So you're saying how would I encourage pupils, or how would I encourage other teachers to?
I think probably, you know, in your own classrooms, what's your go-to at the moment? You know, because obviously it changes term to term and things, doesn't it?
Well, I think that one thing I've discovered in my own teaching in the last year and a half or so is the what if questions. Small what if questions are really an easy way to generate self-explanations and to make generalizations. So if you solve a problem, I've sometimes told my students, or if a student raises their hand and starts saying, like I say, okay, can anyone explain why, we're allowed to subtract whatever, 2 from each side or whatever in this case, or why this is the best, whatever the question happens to be. And if a student raises their hand, this sometimes happens and they're like, oh, they start saying things. They're like, actually, it's hard to explain. I don't know how to do this. I'm going to put my hand down, call on somebody else. I'll stick with them and I'll say, okay, ask yourself a what if question. What if instead of x squared equals 5x plus 12 equals 0, it was x squared plus 5x plus 13? How would that change the solution? I think that asking those kinds of what if questions is, at least in mathematics, a very quick way to get at a generalization in algebra or arithmetic. Change one little thing. What if this were slightly different? You probably won't be changing the problem in a major way if it's a number or an operation. If you change plus to minus, you're probably not changing the subject. And that's an easy way. So I do encourage students to do that. And but I'm not, that's kind of on the side, I suppose, since my self-explanation prompts are really prompted. I'm writing those prompts, you know what I mean? I'm not asking students to be independent very often in self-explanation. So that when I say that I'm encouraging students to say, what if, I brought that up in the context of a whole group discussion, but frequently that's just a bullet point. Hey, everybody, let's talk about this. You should talk to your partners right now and say, what if we change plus 12 to plus 13? What would that do? How would that change the solution? Does that answer the question? I don't know. I can't tell if there's a mismatch between what I imagine my classroom like and the kind of like encouraging students direction that I saw in your question.
Yeah, no, I think it does make sense, because what I'm taking from it is that it's almost impossible to look at self-explanation in isolation from the rest of what you do in the classroom, because the prompts that they obviously feature in teaching math with examples quite prominently. And so for me to say, well, what do you do with self-explanation? Well, actually, it's part of your pedagogy in a broader sense, rather than being able to pinpoint, well, on just like the answer to the first question, on day one I do this and I do that. Yeah, so I think it makes sense to me.
I mean, the other thing is that I'm really, in most cases, students need scaffold. I can't just say, go ahead and explain this. When there's an example on the board and I'm saying students, go through each line, I am encouraging them to be specific is, I guess, another thing. I encourage them to not ignore any symbols. I feel like that's an important mathematical reading habit to really be detail oriented, to really not allow yourself to just kind of skim over and say, oh yeah, sure, I understand the gist of this. I kind of understand it, kind of. Yeah, sure, I understand it. But you're right, it's integrated into everything. But it's also I think you can isolate the self-explanation prompts, but they are prompted. It's like we were talking about in the very beginning, where do I have hopes that students would independently be able to kind of carry off certain self-explanation habits? I would love that, actually. But right now I'm scaffolding them into and providing them with really specific ones. Sometimes doing more than just giving prompts, but really, like I was saying before, either the multiple choice thing or the fill in the blank stuff, to just try to get articulations of general principles out there.
There's a really nice example of that in your book, where you're looking, funnily enough, given what we talked about earlier, I think it's geometry, not proof, but looking at certain principles. So you're looking at the angles inside different polygons by referencing how many triangles you can draw within them. And there's some nice prompts in there where you've got, I think, like a hexagon and an octagon, and you say, okay, so why are there, one of the prompts is something like, well, why are there What happens if there are two more angles? If there are two more sides here, or why is it the case that there are two fewer triangles than there are sides? And you're kind of prompting them to start almost pushing that down to say, okay, so what if this was 5 sides? What if this was 4? What if this was 3? So there's subtle prompts there, but enough to get them thinking. I mean, this is just a chance for me to say, people really should buy that book. People will have noticed, if they've been following me, that I have plugged it repeatedly over the past year, because my partner is a secondary maths teacher, adores it, absolutely adores the book. And it's been something that she says has really advanced her practice. And she's someone who's been teaching maths for about a decade and a bit now. So and is very good at it from what I hear. So if it advances her practice, then I think it can support anyone.
It's very generous of you to say that. I'll go even further. You should consider buying, if you don't have, hundreds of copies of this book. It's very thin, so if your hope is to kind of like stack them or anything, you'll need a lot of them. So you really want to go for volume.
See, I never thought of that. I've always been telling people to buy a copy. I feel like I've missed a trick. No,
you're just going to be disappointed because it's so thin, because it's so short. Book. You're going to need a lot.
Yeah, you've been underplugging, if anything, Chris. I mean,
right.
There are many edubooks, but yours falls into the category of the extremely well written and extremely useful, I think. So the fact that it gets mentioned quite a lot on this podcast, and I think it's testament to the hard work. You were talking about your process earlier on. I think there's a lot of math teachers who are really grateful for that work.
Well, I really appreciate it. I work really hard on the writing. I threw out a lot. My process involved just throwing out many chapters that didn't feel like they were working. I also really struggled for a long time in the writing process to try to nail the tone, or the tone's the wrong word, to try to get the right vantage point, because I find it so hard to write about teaching as a teacher. It's so easy to drift into the kind of patterns of authoritative researcher talk that I think a lot of edu writing falls into. The kind of thing that starts citing stuff and says, therefore, this is what everybody should do. But I feel like we're teachers, right? So we should try to sound like teachers. But that turns out that's kind of hard without sounding flimsy. So I definitely, it's a short book, but I worked really hard on it. So I'm glad and also I'll just say this, it's been very nice to have written a book. People sometimes, I don't know, why bother writing a book? There's so many books out there. The internet is free. You don't make a lot of money off of writing books. That's certainly true in my case. I'm not living it up. Do you know about Scrooge McDuck with his swimming pool full of money? It's not my life, but it's people should write. Teachers should write. Teachers should write and try to sound like teachers. They should work hard on it, but it's more people should do it. It's good. You're both excellent authors, also practitioner writers. We need more of that.
Yeah, that's also very kind of you to say. But I totally agree. The more teachers writing, and then also thinking carefully about the writing process, the better off we'll be. Not least because they'll have spent time thinking about the particular focus of the book, and then we'll have a message to share. Because you're absolutely right. No one gets into education books for the money, but the experience alone itself is definitely worth it.
Absolutely. I'm on the record now, having said that I don't regret having written a book or spending time or trying to write more, however unsuccessfully so far.
I mean, yeah, that's generally how it starts, and then it's only at the very end do you start to feel like you're getting somewhere. I've been banned from writing anything more until the kids have gone to secondary school, so I've got
my. How many do you have? How many kids are there?
They're 5 and 7, so they're,
oh my God,
one's almost in kindergarten, but it's reception in England, and the other one's going into Key Stage 2, which is sort of junior school.
Our kids are, I have a third who's going to turn 2 in a month, but otherwise our older two are, we should have a play date.
Yeah.
Same ages, pretty much.
Yeah, definitely. I mean, we'll have to go over to the East Coast because
Or just meet halfway in some island in the middle of the Atlantic Ocean.
Do you have any words of warning for anyone keen to get started? You know, they might listen to this and think, about Monday morning, I'm going to get started with self-explanation. What sort of guides would you give them to sort of temper their enthusiasm?
To temper their enthusiasm, I would, well, I don't, the words of warning, I mean, what's the worst that could happen, right? Well, the worst that could happen, I think, is that a teacher would say to students, okay, I've heard that self-explanation is great. Go ahead, explain why. Why does this work? And as we were saying before, students can't do that easily. They lack the vocabulary, they lack the conceptual knowledge, they lack. So we support them. So I think an easy way to get started is you've given your explanation. Maybe it's not a worked example. Maybe you're a chalk and talk kind of person. Maybe you're 5 plus 9, and so we can do that for 7 plus whatever. But then after your explanation, I find it easy to add on a pause. What if instead of 5 plus 7 was 5 plus 8? And I think that's a very easy way to get started. And it's prompting students to explain in a concrete way. They'll say, what do you mean 5 plus 8 instead of 5? I said, well, what if it was 5 plus 8? How would that change the solution? What would we have to do differently? Could we do the same thing? Would we have to do anything differently? I think that's the easiest path for myself, the easiest path into self-explanation. Because it costs nothing. It doesn't need to be written on paper. It doesn't matter how you're instructing students. It's a 2-word question, what if? And I think it sets us off in the right direction. What if? No, there's a lot of books called What If. There's the XKCD guy has got a book called What If. You can't do that.
Right. I think that's a really healthy and positive way to look at the response to that question, because because people will, I think, rightly be enthusiastic to get cracking, and so you're saying this is the best way to start. That makes a whole lot of sense. I mean, I could spend hours talking maths with you, Michael, and hopefully this won't be the last time that you join me and Chris and sort of some of the regulars on thinking deeply about primary education. And maybe next time we'll choose an area where you're less of the expert in the room, so we can all sort of push some ideas around. I don't know. But all I said to do is say thank you very much, Chris, for joining me.
Thanks for having me, Kieran.
Thank you, Michael.
Yes, and you know what? Even if I'm not the expert, I'll talk like this. So on anything. Anyway, but no, thank you very much for having me. This was a pleasure. I do hope that we get a chance to chat again.
And everyone at home, until next time, thanks for listening.
Don't you dare say that you're ahead of the United States of America in anything. That is the one thing that will offend an American. USA, USA.